Oh, cool.
So is anyone else joining today?
James will not be joining from our side because he's busy actually testing some thermal cameras with a customer, trying to figure out how to bring thermal camera feeds in quickly and easily.
Okay. Hi, Danny. I don't see. Where are you right now? Colombia or Minnesota? Well, after 40 days, it's my first day in office today, so I'm Brno, Czech Republic. But it's quite an exception those days. Well, I've been in Brazil for a few days only, but I visited Argentina, visited Chile, Bolivia, and from all the countries in Latin America, the Bolivia was probably the best. It's only missing the sea. But other than that, it was quite nice. Drinkable water from the tap. Streets quite safe. I've been walking midnight around the city and nothing happened to me. There was a few funny stories. Like I've seen some stands with street food, and I asked what meat is it? Like what carne? And I've been asking, is it like cerdo or pollo or other things? And they said jungle carne. So as you can guess, I've been not eating that place. So is anyone already here? Quite a big crew today. I believe so. Danny and Danny, you both here. I see.
Yeah, I'm here. Hey, Pavel.
Hey. How's your girlfriend?
You got us mixed up. Dan's the single one. I'm the one.
Come on, it's not that hard to mix you up. You look same.
That doesn't mean you don't have a girlfriend.
I have a wife.
Okay, guys. So today from our side, there is Jiri Zbiderovsky. There is, you know him already. There is Philip, a sales guy. There is Eric, the sales guy, and Maciej, our new technicians. I believe the meeting will be Jiří. Jiří will be leading the meeting, right? And he's sharing the screen. So, yes. Jiří, stage is yours.
Okay. So we have to go through the merging trajectories or merging cameras to one cube. So this is our, let's say the stream is our local stream and it's already configured, but I will show, let's take a look at first how it looks like.
Jiří, can I stop you? Can somebody record the session?
Not to do yet.
Můžeš to nahrát, Jirko, nebo?
Já to nevidím. Nebo...
I think Pavel, maybe the meeting host, which should be you, can record this.
We don't pay extra for recording.
Okay.
I don't think I can do that. Recording unavailable. You are not allowed to record this video call.
Okay.
Okay, that would be great.
Okay, let's wait for the start recording. It's already recording, or is there an issue? Okay, maybe just have some presentation. So this is how it looks like on the end. We're just merging for. Okay, the stream just started again. So this is the same intersection which we also presented on the intertraffic. So there is 4 cameras in the center, and the task is to merge the trajectories from these 4 cameras into one place, into one space. Sorry, and then you are able to do the same gates, same zones like you have just one camera. Okay, so this is our task today for this meeting. Recording is running, Denny.
Yes.
Okay, perfect. So, what we need, I will just use one camera as a how to do that, how to work with this, because usually you have to do the same for all of the camera and then merge the cameras into Cube. So I will just show you just one camera, how to prepare it, and then I will show you how to put it together into Cube. So we need to add the stream. So let's name it. Use the stream. And wait for the image. Okay. So this is our camera. To be able to correctly do the cube or correctly manage the trajectories, we would need to set up the camera parameter. It's undisturbed parameters to fix the I don't know how to say distortion of the lens. So I would load already predefined camera parameters, and as you can see, it makes the street which should be straight. It makes the straight in the image. There is no angle, no spline of the road, so it's really narrow right now, and it's undistorted image. So let's save the settings. We also did the same also for your camera, for your doubled camera, but I don't think that we already released the camera metrics, but we are in the preparation of this camera metrics for your cameras. So, yeah. And now
that's the reason why I needed you to send the cameras.
Because there is a special steps how to get the camera parameters. So we record the video with this special board, and then it should be or it has to be processed by the application, and the application will just get the camera parameters from the video. So it's automatically detected the camera parameters, but we really need to have physically the camera here on our desk to record special video, and then we are able to process or to generate these camera parameters.
Gotcha.
And I have to say that we tried to do the merging of cameras without these camera parameters, and it was really hard to do that. So in my opinion, you will always need these camera parameters to be able to do the merging of the cameras.
And you have our wide angle still, but I think they said the digital camera failed, or we needed to replace it. I didn't know if you had gotten the replacement yet.
We just exchanged the camera lens. So I would suppose that the hardware of the camera is the same. The wide or narrow camera is the same. You just need to, or there is just a difference in the lens.
At this point, it's just a difference in the lens.
Yeah. So we just exchanged the lens to the one working camera, and then we record the video. So It's not really necessary to send another device. If you can just confirm that it's the same hardware, then it's okay.
Perfect.
Okay, so we have the camera parameters right now. We fixed the distorted object, distorted image. Then we have to do the georeferencing. This means that we define a few points in the camera view to which we define or find the GPS position. usually we use Google Maps location. So right now I need to find what's the camera. So we saw building. I think it's this way. Yeah, I think. So, for example, this point, we have to find this point at the Google Maps. Scroll up. So for our case, it's so it's somewhere like here. Let's put it on the cross. Okay, so let's take this point. With right click on the mouse, with right click on the Google Maps, you will get the GPS coordination, and just Control V passed it as a GPS position of this point. Now we have to find this point, so let's put it again on the crossing. So it's this. So take this GPS position and do the same also for the rest. So this pole. And as you can see, once we add a more GPS position, it will calculate the error. And as you can see, if there is a big difference, then the error is quite high. So our point or our goal is to reduce the error below the 1. So let's take this point, the last point. It's here. Okay, so we are fine. We are good with this GPS positions. So let's save the settings. So with this georeferencing, we also get the trajectory speed, or let's say the object speed in kilometers per hour. So it's also used to generate the average, or let's say average speed of the vehicle in this zone. So the best is to choose the points really along the whole image, just to cover. It's really wrong if you put these 4 points on just one place. It will not work basically. So the best is to choose the good location for the points where you are able to find these points on the Google Maps, like all light pole. So it's good readable on the Google Maps, and the points has to cover the whole image, not just a part, but we need to cover the whole image of this point. So that's the preparation for one camera. Basically, we need to do the same also for all of the cameras, which should be added to the cube. So right now I will disable this test, and I will show you one by one how it looks like. Okay, let's wait for it. So this is the first one. As you can see, we already did load the camera parameters. We also did, there is no GPS reference here. This was just disabled. Okay. Save settings. So let's check the camera number 2. Also disabled. So let's confirm. Camera parameters. It's already loaded, so. Okay, that's fine. Let's check the third camera. Camera parameters. Okay, it's loaded. And let's check the fourth camera. Show currency. processing. Let's check the camera parameters. Okay, it's fine. So it's fine. So all of these 4 cameras is running. Each camera has one arm of this roundabout. So we are ready to go to create a cube. So for this, we will add a source and not the RTSP stream, but we will choose the cube. Select the name. Okay. And now we have to generate the background image. Basically, we have to define where we want to map this camera to the image, to the one space. So for this, it's really simple. Just go to the Google Maps, do a print screen, basically snapshot of this roundabout, store it. Okay, put it here. And now load this image. Georeferencing. And just put it here. Okay. So we loaded this background image. It will be used as a reference image. So right now we have to do the same like for the camera. We need to georeference this image, and basically the camera will detect position or will convert the position of the object to the GPS position. So we really know where the car is in the GPS coordination system. And when we do the georeference in this background image, in this cube, we just simply present or map the trajectories or the object trajectories with the GPS position to this image. So because we know the GPS position of this image, then we are able to map trajectory for from each camera to this cube. So let's do it. So it's again the same. We need to find correct position. So let's choose, for example, this, for example. And yes, Stacy, you would like to ask for something?
Do they have to be the exact same positions you already selected? Or if it's, can it be slightly different in this screen?
I don't get it right now.
The geo-reference points, should they be the exact same geo-reference points you already used?
In the camera?
Yes.
No. It's independent. So
okay.
I just need to map this image to a real coordination system, to the GPS system.
Okay, just asking. Thank you very much.
So you can choose any point which is really good, readable at the map, and we have to do the same like for the camera. It's not necessary to do the same points. Okay, I need to find the Google Maps. Where is it? So let's choose the point. Get the GPS position. Okay, select the section. There is one advantage of this let's say mapping, because sometimes the Google Maps doesn't have or doesn't record or make a photo of this intersection because there was some reconstruction and it's not yet on the Google Maps. So in that case, you can just use some drawing, some technical drawing of the intersection or of this new intersection, and you can do the same. So basically, there will be no map, but there will be a technical drawing which you will do the georeferencing. So it's really independent. Even if I use a blank page, or and there could be basically anything as a background image. You just need to correctly map the position to the GPS coordination.
Do we officially support 3D models, or it's not propagated into?
It's not yet propagated. It's still maybe in some test branch or something like that.
Okay.
So that's the georeferencing of it. So right now we are ready to go to put the camera there to this roundabout. It's just simply drag and drop. Okay, and we need a camera number. I think it's number 2. To the left, I suppose, yes. So as you can see, we're already getting some trajectories to this background image, to this cube. So because we already did the georeferencing of the camera, then he is really able to map the camera to this georeference background image without any special requirements or special tuning. But we have to do some fine tuning. So let's check the analytics settings. Cube. Okay. Crashed. Again. Go to the cube, and as you can see, you can disable the view of the camera in this background image. So as you can see, for this camera, for example, it's nearly mapped to the correct places, but we have to fix it, or it's usually as more as you put it correctly to this map, you will get a better results. So our task is right now to correctly map the position to the background image. So we can again choose some points on the map. For example, this. Crossing, and as you can see, it's already moved on this cube view, and now we have to fix the view or the position in the camera in the cube. So as you can see, once I move just a little move, and it will fix the position nearly to the correct in the background image. So I have to do the same for each point. Okay, that's cool. Okay, and let's fix the. It will require some time. It will take some time to put it correctly. But it's okay, I think, right now. So we have to do the same for each camera again. Because as I say, the more precise the points will be, or the mapping will be, then you get that better results in when you merge the trajectories into one. Okay, let's keep it like that. Settings. Let's do the same also for first one. Check it, so move the points. Point somewhere. And let's fix the mapping. Okay. Seems to be fine. Good. So this is the preparation for mapping the trajectory to correct space, and usually we recommend to remove some or to create a no detection zone, because sometimes there are detected cars like on this image. There is parking lot and usually we don't need it, so I would recommend to draw a no detection zone around this corners where we are not interested in the zones. So let's save the settings. And it's usually good to check if you disable the ground prediction. So just switch it to the manual. And that's it. So let's check also the ground prediction on the various camera. So let's do the no detection zone. Okay. And check the ground prediction. That's not true right now. So let's check again. Yeah, it's okay. So we prepare the camera for the merging. And right now we have to add a tracker settings. So a new rule how the trajectories should be merged together. So you can choose for which categories it will be used, this merging. So we want to use it for all type of vehicles. Bicycle, pedestrian, pram probably will be not there. Travel time, min and max means how long it will take from one camera to another camera. So I will show you to wait for background image. So basically we have to draw a zone at first camera and draw a zone in the second camera, and we have to define that we would expect that the car in this zone will hit the car or will be the same car also in the zone in the second camera. So let me check what's the... Okay, it should be... It's a different order. So this is this, basically. So we have to create a zone. So let's draw a zone. Let's name it like, for example, out. Apply. This car is basically the same car like here, so we will draw another zone, like input zone here. And again, name it. Apply. And now we choose from which zone to which zone we would expect that the car will move from first camera to the second camera. So, and that's the time, how long it will take from this zone to this zone, so we can expect that the car will not take more than 2 seconds. So let's save the settings. And let's check. Okay, we have to wait for initialization. Okay, maybe the stream also restarted right now. Yeah, and I have to. It really consumes some power of the CPU. So usually we have to disable everything except the cube on this device. So let's check it right now. Okay, disable all not necessary thing. Okay, let's keep it like that. So for example, here we have a 124 ID. There will be two cars at the same time, but in the end, the ID will be switched to the first ID of the car. So let's take another car on the input. Or for example, this one. It's 105. There was 108, and on the end, it's 105. So it's really merging the trajectories between two cameras because there is an overlap of the cameras. So he can decide that it's the same car and assign the same ID or assign the first ID from the first camera and use it on the end, basically. So that's just from two cameras. So in the case that we would like to basically we have to do show one more time, because there is also another arm or another way how to pass the roundabout. So let's wait for it. Yeah, to this one. So as you can see, there is also another way, another path where the car can go. So we have to do the same like for this zone. So we have to define a zone as out to, for example. Create an in zone. And we have to configure a new rule from out to into. And again, we have to select all cars. And give it just 2 seconds as a travel time between these two settings. So right now it will be also merging the trajectories from in this road. So your task is to choose good position for these two zones, for this out zone and in zone, to be able to correctly merge trajectories between two cameras. And on the end, you will I will enable the already configured. You have to wait for a startup. So on the end, you will get tracker settings. So you have to define 8 rules to cover the whole intersection, to cover all this whole roundabout. So it's really, I will show you on the definition. So there is this point, one rule here, third here, fourth here, and then there is under the 4 rules for this sideway. So 1, 2, 3, 4. So at the total there is 8 rules for the tracker to merge the trajectories between 4 cameras on this one roundabout. It's really, it looks I don't know if it looks strange or difficult to configure it, But if you do some, if you already do some intersection, if you already did this merging on some intersection, I think it's pretty easy. You just need to understand what's going on, that you need to make a GPS position for each camera, GPS position of this background image, and then you have to choose correct places, correct zones where the trajectory should be merged together. And voila, it's working.
So in a standard intersection would probably have at least 12 rules, because you'd have one turning left, one turning right, and one going straight from each approach.
It depends. For example, you can use, the more you can use from one camera, it's better. So it depends on the camera view of on this intersection, and you just need to, you have to take a look what you are able to see from this one camera, and you only have to find where it's not working. So, for example, if one camera is, for example, if one lane is not correctly detected from this one camera, then you can add a second camera and focus on this small place or small area to cover it with the second camera and make the merging of the trajectories only on this small zone. So it's not really necessary to merge. I don't have any other examples right now prepared.
Okay.
So maybe if you already have some location where you want to use it, we can go through this, and we can go through this with you, and you will see what's possible basically to merge into one place, one space.
Awesome.
Because of course, if there will be a huge traffic on one zone, then it's really hard to define which car is which on this camera. So usually it's good to choose a good zone with just like here. It's really simple because there is one intersection of these trajectories, and it's really easy to define the place where to put the zones. But in the case that there is a huge traffic and the car just stopped in the middle of the intersection, it will require some some experience. Yeah, some experience and fine tuning where to correctly put the gate or zones.
Very cool.
And of course, right now you can do the same like in the camera. So, for example, I can put a gate from here, second, 4, and do the OD metrics. So I can just simply and right now I have an OD metrics of this roundabout.
Very cool.
So if you are good, or if you do the best with the merging, then you can do anything with these trajectories. So any question or?
Yeah. This is James. I just want to, from managing expectations with clients. If the roundabout, in this case, if the roundabout gets stuck, a bunch of traffic backs up, does the max time then kick in and start breaking the IDs of the vehicles apart? So where you were showing 105 made it all the way around and it ended up with 105. Had it gone for, say, 7 seconds, would it have kept the 108?
Yeah. So in that case, you have to, if you know that there is if there could be a big delay in the throw time, then you have to increase this throw time.
Okay. All right.
because you are not able to define if it's still the same car, or you have to increase the start time. There is no other route. Let's say we have some advanced configuration, but it's you can enable the visual similarity metrics, but it will require more performance, and also it's some alpha version or beta version. So right now I cannot recommend this feature. So use just only the time or the metric, which is the start time. So you have to define, for example, 7 seconds, 10 seconds, just to be sure that it will correctly merge the trajectories.
Thank you.
Yep.
Now there is a widget that is used in the demo video that shows origin destination matrix with all the different colors.
I think it's in some side brain, so it's not in the official release, but it's only the presentation of this data to some.
That should be part of 118.
Yeah.
Okay. Which is
Maybe
coming
you
out
can
this
check
year?
if you can change the audio metrics into something else. Maybe the setting is already there. Go to settings.
I don't think so.
You cannot switch here.
I think it was some side branch. It's not an official release.
Yeah.
It's only about the presentation of the data. That's it.
I know one of the requests we had put in was, and I understand doing a full OD matrix in 15-minute increments was very, I guess, hard to program, but we had put in a request for one origin and multiple destinations. So it'd be a single line in 15-minute increments. We found another option. I don't know if it'd be easier or harder, but we were able to do a super widget by creating, our left hand, a through, and a right hand as a super widget. But we had the same problem. It wouldn't pull in the 15-minute time blocks.
So there is a lot of traffic on this location.
Mm-hmm.
It's still the same. I would say the limitation is the same like in one analytics, one camera. So in the case that there is a lot of traffic during this 15 minutes, and you basically, if there is more than 10,000 trajectories, 10,000 objects in less than 15 minutes, then you are not able to use, or you have to shorten the time block, for example, to 5 minutes, and then you have to do some post processing in your backend. We don't have any solution right now for this case.
No problem.
Or you
Jirko?
can yeah.
Funguje nám, já když jsem byl u nich, tak mě nefungoval webhook OD matice. Myslím, že teď už by to mělo fungovat. Když skočíš na webhook.site, nastavíš tu matici na jednominutový inkrement, dokážeme to posílat jako minutový time block.
Jo. Okay. Pavel wants to show you how to send this OD metrics to a web group. So I will open a test site. Okay,
and let's do 1 minute increments so we don't have to wait long.
Yeah.
Cool. Let's add this widget. Where is it? Okay, and now we have to write to receive. It's already there. So right now I received the OD metrics on the webhook. So there is the naming of the origin and destination, and then there is what is the naming, and then there is metrics with the data.
So 1 minute time block is working. We can do it 15 minutes.
Mhm.
And then from this website, you can do CSV export. And that basically give you the Excel file with all the information you need.
Awesome.
There is some
Thank you.
And in the same way, you will be able to send it to the Flow Center and have the aggregated data for a long time in the Flow Center once it's released.
Let's check it. Yeah, here we have some other data. So it's always sending every 1 minute. It will send the data to the server. Let me use it. So we use the car with some data. So you will get, for each category, you will get the OD metrics, like on the dashboard, that you are able to choose or select what kind of, if you want to just choose, show the cars, then you will get only the amount of the cars from this OD metrics.
So it's sending origin destination metrics every hour, every 1 minute for every class that we have.
Yes. And then you can push this data, for example, to some database and make some post-processing, like make a 1 hour summary, 24-hour summary, and so on.
Okay.
So, anything more?
This is very cool. Any idea of timelines as to when we will get the camera distortion matrix numbers for our cameras?
I think it has to be prepared by David. So, Pavel, did you talk with David regarding this?
Okay.
Pavel?
Yes.
Yeah, I know what we
know.
do it.
So yeah, it's. I think if you make a priority on this, then it could be ready this week. I think. Or maybe do you have any already installed intersection with this camera where we can test these parameters
I'm sure we do.
with some remote access?
Yeah, let me see what I can, especially the 2-camera system I know will be the most popular for this feature. So let me see where I have some installed that have the wide angle as a priority.
Okay.
Okay.
So it's good for us to test it somewhere, not
Yes.
just in our office, but also on place.
Awesome. Thank you.
You're welcome. So, any other issues or questions which should be answered by us?
It's a lot to take in.
I don't want
but,
to create more issues.
yes.
Yeah, I'm pretty sure if you choose some of your location, then we can have another meeting and we can go through this configuration, or we can at first prepare this configuration and then we can present you our solution, or let's say our solution on your cameras, and then we can again explain you how to do that.
Okay, thank you.
So, Dennis, Stacy, now we know when you sell it how difficult it is.
If anyone can find a way to make it easy, it's me.
Okay.
Okay,
See you guys.
thank
Thank
you.
you.
Thank you.
Bye.
Bye bye.
Jirko, díky moc.
Bye.